All attendees are in listen-only mode.
Good evening. This is Mark Fleming, and on behalf of CERECdoctors.com, we'd like to welcome you to tonight's webinar, Introduction to Suprinity, Aesthetics Through Strength, Applications, and Indications. Before we first get to our speaker tonight, I want to remind all of you out there about make sure you RSVP for the Scientific Symposium in Las Vegas in October. Our speaker will be there with a list of other great speakers. Another important thing is make sure you make your room reservations. We have a block of those, and we don't want you to have to be run out and get another room. So make sure you make those reservations right away. Alrighty, tonight we have the pleasure of Vanik Jinoian be speaking to us about Suprinity. He owns one of the largest dental laboratories in Switzerland. He's been instrumental in the development of CEREC in-lab system and many other industry advancements, and is very involved in research, development, and helping companies ready their products for the marketplace. His extensive knowledge has made him one of dentistry's most respected authors and speakers in the areas of software, milling machines, and materials. So without any further ado, I'm going to turn it over to Mr. Jinoian. Vanik?
All right. Thank you, Mark. Good evening, everybody. This is my first web. Oh, what happened here now? You still hear me? Hello? Mark?
You're good, Vanik.
Something went wrong here?
You're good.
You hear me, huh? Okay.
Yeah.
So this is my first web seminar here in the U.S., and let's see if everything goes well. CAD/CAM takes over the world. This is what I, call my title. And this is really what we've been seeing everywhere in the world. Everything is going to automation. People are really starting to look at methods, how they can get a better quality for work, which really would usually take lots of manual work. So what we can really say with CAD/CAM taking over the world is, with all these softwares nowadays which are coming out, with all the milling machines coming out, we're suddenly starting to see that we can do all types of work. We know we can do crowns, we can do bridges, we can do frameworks, we can do all these kind of things with CAD/CAM. And we in our lab, we're also doing all our ortho aligners now with CAD/CAM. We're starting to do denture setups with CAD/CAM. We are at the moment working on a 3D face scanner, which Dr. Balzer and me have been using since about 6 months to set up also dentures with the real head CAD/CAM way. So we can say CAD/CAM is really taking over. The question comes up is, is manual work out? Well, we can't really say manual work is out because, I mean, when you cut a prep, you still work manually. It's not the computer which cuts it. But what we can say is some technologies which are done manually are going to be out. And this is one of the things which I always try to tell my colleagues is, why would you use systems like pressing? Because, if you look at all these steps in pressing, you have to block out your dies, then you have to wax it. After waxing, you have to start spruing things. After you sprue it, basically you have to go and you have to invest them. You have to go to a pressing furnace, press it, die west it, sandblast it out, put it into acid, and on and on and on. And after everything is done, you can start glazing it. This is all manually done. Why not do it 7 to 12 minutes with a CEREC system? That's why, for me, I don't understand labs nowadays which are basically still pressing if they have such a nice small machine like the MCXL. And dentists are smart enough. They have realized that because you can mill it and you get a very good quality product. And this is what I'm trying to get is, the manual type of work like we have with pressing, that type of work will be out because it makes no sense to work manually if you have machines like this. What we've been seeing tendencies happening with the preparations, Dr. Balzer and me, we did a study in around, I think 2007, and we wanted to see what types of preparations that we get from different types of dentists. And the majority of the preps reduction, like here, which you see on anterior crowns, were around 1 millimeter reduction. On premolars, we used to get about 1.2 millimeter. The necessary 1.5 millimeter, which would be necessary for many of the techniques, we never used to get, but we still used to, make those crowns on them. Nowadays, with the new materials which are coming out, like Inamic, we can go to minimal invasive preparations, or Suprinity. We can go to preparations where we don't have, those kind of issues. So the tendency which we are seeing everywhere in the world is minimal invasive preparations which you don't have to reduce the tooth by 74%, but you can only partially reduce the tooth and make your restoration. But for that, we need, new materials. And the tendency in materials is basically going to materials which can do this. What we know is the most popular material on the market up till now has been Emax. Emax has been very, very successful, and now comes basically the next generation. So Emax had its time, and now we are starting to see new materials come on the market. And the new materials, that's what we're going to talk about now. This is, some of the materials which we've been using, which is called Suprinity. So Suprinity, what is it? Before I explain what it is, I would just want to let you know it's a product which is basically made by Degudent, okay, made by VITA, and was basically developed jointly with the Fraunhofer Institute. It's a very famous institute in Germany. So these two companies have invested in this product to get something new on the market. They said, why not get a product which makes life easier, which we get nice aesthetics, and which we get more strength. So if you see the history of, lithium disilicate, 2005 it hit the market, and now comes basically lithium zircon silicate. So what do I mean with that is, 1950, we started with porcelain fused to metal, and it's still being done nowadays, but we can really see there's a big decline. 1991, Mark II came on the market. Before Mark II, we had just like a feldspathic porcelain, which we were using. I started in 1990 using the CEREC system, so basically I had some of the old material. But 91, Mark II hit the market, and it's still going strong in some markets. Then in 2002, porcelain fused to zircon oxide started getting onto the market. 2005, Emax lithium disilicate hit the market. 2009, the full contour zircon oxide. Some call it Brookseer, some call it just high translucent zircon oxide. 2013, the first hybrid ceramics started coming out. True hybrids like Inamic, which is for really minimal invasive preparations. And 2014 is now basically the new Suprinity, the new lithium zircon oxide. So what is it? It's basically, we can say it's lithium oxide, it's silicon dioxide, and about 8 to 12% of zircon oxide inside it. And we know in some of the studies like Giordano was showing, zircon oxide has a strength of 970 megapascal. So it's one of the strongest materials they've added into this composition to not only make it stronger, but to give it a lot of advantages during the milling process, which you'll see a little later on. The material has a very, very smooth structure, extremely smooth compared to some of the lithium disilicate type materials. Through the smooth structure, you will get benefits like less chipping during the milling process. You get a very nice wear characteristics towards the opposing, naturally very, very easy to polish, and you'll see some of these features very soon. I want to speak about the experience which I've been having with this type of material, and we have now been beta testing it a little bit more over the 2 years, and it's a very, very interesting product. And it seems that VITA has really done their homework, because they started listening to us about things which we didn't like on the Emax side, which needed some improvements. Because basically you can see Emax is an excellent product. It has really done a good job, but there's always place for improvements, and those improvements I want to talk about. Okay, so one of the big difference to the blue blocks, if you see here like a blue block, is this amber color block or like this clear type block. And you say, well, what is the real benefit of having a block which is clear like this? And I really wanted this to be clear, is that basically when you put it on the model or if you put it in the mouth of the patient, you can see if your crown is down. If your crown is not down, you will see it instantly and you know where I can grind on the prep. So you don't really have to grind inside the crown and maybe hurt the smooth surface with a rough diamond. You can just slightly do adjustments on the prep if necessary. So I can see through it, I can see what's happening inside. With the blue blocks, basically you can't see what's going inside. So it's a pity giving up this chance. It would have been, I'm sure, also easy for Emacs to make the blocks more clear. But this is a real big help. And we see this also here. This is an anterior restoration I did, I think about 3 weeks ago, 4 lowers. And you can see how nicely they are sitting here. If they would not be down, you would see like a very dark black line this area here. So this is one of the biggest advantages compared to the blue blocks, where you can't really take the advantages and seeing through it when you try them on, if you want to try them on. Okay. Then another thing is, if we look at some of the old ceramics, like you see here, the old metal ceramics, how they have worn off the natural teeth. This doesn't happen with this new type materials. I mean, lithium disilicate is excellent, and also VITA Suprinity with very, very fine grain structure gives us a very big advantage to wear of antagonists. So it's a very antagonist-friendly type material because of its very fine grain structure. It's very similar to, you can say, Mark II. Okay. If we look at some of the materials, and this I try to do in the lab myself, I took always the same crown in the CEREC machine and the same construction, and I milled the different types of materials with the milling strategies which Zirconia has. And what you see is Emacs is the material in the milling process which has got the highest chipping rate here on the margin. You can see how it chips. Then Suprinity is much better. The best material would be actually Mark II, because these actually Inamic is the best. Porcelain fused to metal, we can't really consider chipping because it's milled metal and ceramic veneered, but Inamic is actually the one which has got the least chipping of all the materials, mills the best. But Suprinity also mills very, very good as a glass type material. And you can see it here once more in a bigger picture. Comparison of Suprinity to Inamic, to Emacs. You can see the Emacs type material tends to chip. You can see that very nicely here. Here we don't have, even though they have the same crowns, okay? And you'll say, yeah, but I don't experience that. And you're right, because you're not really allowed to mill it this way. Because Evoclar, in all the instruction manuals, they say don't mill under 1 millimeter, okay? So if you do what I've done here, this is wrong, because this crown ended at about 0.4. So that's why it chipped. But then I started asking the question, so how do I do a veneer which is very thin on a milled Emacs if I can't go under 0.4? So that question comes up. So usually we end up milling thinner, and then we get this problem. Here, that was the restoration which I showed you before, to just show down here, somewhere it always ends up very, very thin. And when it ends up this thin, basically, we will get on lithium disilicate, we get chipping. On Suprinity, we also, you see a very, very fine chipping on this little edge here, but we don't get like very strong chipping like we used to get on some of the other materials. But keep in mind, this should not be milled this thin. VITA has done their own research, and I got some of their pictures, and they show the edge stability of Suprinity compared to lithium disilicate is really much, much better. You have less chipping around this area. And this really shows up on margins which are under 1 millimeter thickness. Okay, let's go to the next picture. Gee, I think I went one too far. You can see here very nicely on abutments. When I make ceramic abutments, out of materials like Suprinity, like you see here. You see how nice and sharp this mills. If you try to do this with some of the other type materials, basically it tends to chip. Okay, and I'll talk about this a little bit later on. About abutments with the hole inside it and how we do it, because for me it makes no sense to have blocks with holes inside them. Okay, and I'll show you after why it makes no sense to have blocks with holes. If you look at the products by light conductivity, and again, showing this is not really very important. But what I like to say here is, Inamic, Suprinity, Emax Mark II, they are all in the same league. Okay, we can, maybe this one shows a little bit darker, this one shows a little bit lighter, but basically they're all about the same with the light conductivity. Where it starts to get a problem are like the full zircon oxide. It's not so bad. Porcelain fused with zircon oxide or metal, they don't let the light really through. You can really see that these crowns are in the mouth. It depends where they're placed when the light is shining in the patient's mouth. Good. Then, let me go to the next one. So with Suprinity, we have an excellent light conductivity. The light goes through. It looks very natural, has a very nice chameleon-type look. Under UV light, these crowns, they start to look up a little bit differently. One of the nicest materials on the market at the stage is basically, we can say, it's Mark II. Has a very, very nice look, very nice fluorescent look under UV light. Inamic, Suprinity, Emax, all, they are, you can say these two are about in the same family. What is very, very bad are the full zircon crowns. I had to enhance this picture to make it lighter because it was actually black. So this shows if somebody does a pure full contoured zircon oxide, and if you do something in the anterior, the patient goes to a disco where there's like blue light or some kind of a theater, he's just got a black hole in his mouth. He's got a black tooth there. People start saying, yeah, we can put some fluorizing glaze on it. If you do that, what happens is usually after bonding a crown and you start polishing somewhere on the crown, basically you'll hurt the glaze and your crown becomes spotty or patchy under UV light. So I don't believe in this, UV enhancing glazes. I think the material should have enough fluorescence. If you look at these two crowns, Emax and Suprinity, what we can say is it depends on the translucency level of the block and the color of the block. If you have let's say an A1 or a 0M1 block, you get a more fluorescence than if you have an A3 and let's say a medium opacity or a T-type block from Suprinity. They don't have as much fluorescence as the lighter ones. But again, I think these are sufficient the way they are. If we compare them, if we take a Mark II and we compare it to a natural tooth, this is naturally what we would like to see. These are the best looking under UV light. I use this light here. You can find this on the internet. It's black gray UVL -21, and I laid the crowns on here. I took the camera, made the picture from top without any flash, because the flash will change again the look of these crowns. And I also turned down the room lighting, so I could really use only the UV light from this little lamp. It's about $70 or $80, this light. If we look at the aesthetic appearance of these materials, what I must say is the nicest looking crown in the patient's mouth I've been finding now is the Suprinity crown. This is comparing it to some of the other things, comparing it to Mark II or comparing it to Inamic. What we have been seeing is some of the lithium disilicates tend to look a little bit grayish in the mouth. It can also happen to Mark II. We can see already in this picture. It tends to look a little bit grayish. The nicest looking material is really Suprinity or the Inamic. Inamic is also not so bad. What is very, very poor looking are, again, the full contoured zircon oxides, which somehow have become popular. What we also see more and more is the need for, the opal effect. So that's been integrated very nicely into the Suprinity and naturally the fluorizing side of it. This has to be, otherwise people not use it. So with Suprinity, we can start doing crowns, which can be out of, monolithic, or we can start adding porcelain to it. Here a case, basically a no prep situation. The patient had these two just impression made, and we just made these two Suprinity, what you call veneers or whatever you want to call them, put on with no prep. And they come out like this. They don't tend to gray at all. That's one of the nicest things. If you start looking at, how simple is it to, and speed of production, the fastest crown which we can make at the moment in a dental office or in a laboratory in its speedway or in its easiness to make is an enamic crown. Then after that comes naturally the Mark II and then Suprinity. Porcelain fused to metal is basically the crown which takes the most time. You have to have your metal frame, you have to do your veneering. Porcelain fused to zircon also takes a lot of time. So basically, enamic, Mark II, Suprinity are the three products which I think can be produced very, very fast, chair side. Also, the milling time of Suprinity compared to some of the lithium disilicate are faster. It mills easier, it mills nicer. Okay, let me just go on next picture here. Manufacturing costs. The cheapest to manufacture is the enamic. That's what we have been finding. After that comes Mark II, and then comes Suprinity. The most expensive to manufacture in a dental lab is the porcelain fused to metal. Okay, and the same we have been seeing also in the dental offices. Now you say, why is Suprinity before Emax? And you will see that afterwards, because there are many steps which we don't need to take. We don't have to put any paste inside it for the crystallization process. The crystallization is a little bit faster. So there are many steps which are shorter. That's why Suprinity is in front of Emax. Here, 4 lowers, about 3 weeks or 4 weeks ago, those were the ones which you saw before as translucent blocks, which you could see through them. Labor time used on these 4 crowns was about 26 minutes. So that's the time I worked on it. These crowns have no enamel layering on it. Okay, they're monolithic crowns with just a little bit color stains and just put in. They have not even been bonded as yet. So the dentist just put them in, and I made the pictures because I had to leave the office. So I have to still get the pictures now with the tissue okay and everything. But the idea was to just show you how little labor is used to make 4 crowns. And these are all the pictures just in one shot, so you see all the pictures which you saw before to give you an idea how they looked on one picture. Now, strength-wise, this material is, we are talking on biaxial strength of around, I would say about 550 megapascal. So the deviation goes, up to about 620. Deviation of lithium disilicate is bigger, so the material basically, ends up around 450, and here we end up 550. So we can basically say that Suprinity is about, 100 megapascal stronger than lithium disilicate. We can see very nicely on the survival rate, on the reliability test, the dynamic load, that Suprinity is just far more superior. What we have been doing in our lab is when we mill a Suprinity crown like you see here, we always polish it, okay? So when I do a Suprinity crown, before I go through the crystallization process, you will not find this in any of the manuals. I polish them because, first of all, it polishes very easy in this stage. You can grind. I'll show you after what kind of grinding instruments I use. We rubber wheel it, and then we even diamond paste it so it shines like this. Then I go through the crystallization process, and it comes out like this after crystallization. Basically, the crown is finished. You don't have to bother. If you want to add stains, you can actually add stains like you see here, and do modifications. But usually, from canines backwards, you don't have to bother about stains. And you say, why do you do this? It's a very simple answer, and I got that answer through window glass. If you take some kind of rough instrument and you scratch your window, you'll see everywhere like white scratches. Now, if you put enough scratches, that whole window looks white. Same thing when you grind this glass. When you grind, you get scratches, so the crown looks white. So for me, that says, okay, if something looks white, it'll never be nice chromatic after I've melted it, after I've crystallized it. So by doing the polishing process, I get much more depth. The crown looks deeper. The crown looks somehow more chromatic. And that's why I try to polish it before I crystallize it. And like I said, if you want to stain it, you can go ahead. You can use the new accent stains, and you can modify whatever you want on these crowns. Just a reminder, if you put a brown line, you always have to put something white next to it. If you want this area to look out a little bit, you have to put a little bit white color here. If you want to make it go in, you have to put a dark color. So you always have to put a contrast color, white, dark, or light, dark, to make something look more enhanced. Here, the same Suprinity crown, which you see here, was basically also polished before and then afterwards crystallized and just a few stains added, if you want to do that. Usually we don't do that on molars. Patients complain if you do something like this. So this is not only for show here on this picture. Okay, so we do step by step this case, which I showed you before. The impressions have been taken, no prep. Construction was done with the CEREC software. The material was selected, and basically, come on, design was done, everything was finished, and we milled our parts. And the Suprinity veneers were milled. And for grinding, I use this product here. This is called Diamond Stone, which you see here. This is by a company, Jota, out of Switzerland. Jota is owned by Meisinger. So it's the Swiss subsidiary, whatever you want to call it. And this stone was actually not meant for Suprinity. It was meant for zircon oxide. But when you grind zircon oxide with the stone just wears off like nothing. But if you use the stone on Suprinity and on enamic, it's unbelievable how nicely it grinds. It gives you a nice, smooth surface. It cuts very easy. And after the stone, I use this gray ceramic polishing wheels. These are just standard polishing wheels to pre-polish ceramic. And with these polishing wheels, you can basically polish all the scratches away. Because what you see here, this matte Suprinity, is full of scratches. So after polishing, it gets clear. So before it looks like this, and after polishing, basically it looks like this. On this one I see nicely, this crown is not fully down. So you see this little white line here. So it's not fully down, it's hitting the tissue somewhere here. Okay? So this really shows me by looking through the crown if it's completely seated. Then we go to the crystallization process, and for the crystallization process, since these are veneers, we have to lay them on cotton tray. So we don't use any of these pastes. So when you use cotton tray, you only take a small amount of cotton tray like you see here, and not put this cotton tray on the whole big tray, only here. Because if you put a big piece of cotton tray here, what happens is it takes the temperature away, it reflects the temperature, and your crystallization will not be very well done. Or if you have crowns, we just do it on these platinum pins. We put the crowns on these platinum pins here, and we go through the crystallization process. We don't want to use any of these pastes. That's all fiddling around, all time-consuming. You have to clean out those pastes. It makes no sense. If the material is stable enough, and the zircon oxide does it to the material, which is inside there, that about 10% makes it stable. So basically, you can put a platinum pin in here. Don't use any ceramic pins in here. Just use these platinum pins which you can get, and you put these 4 crowns here, and you go to the crystallization process. It comes out, and it comes out high, shiny if you have polished them. You don't need any special furnaces. So any furnace which is on the market, like you see here, there's so many furnaces, you can use any manufacturer's furnace. You don't have any special curvature which you need to go to the crystallization process. That's one of the nice things that they really said, okay, let's not make this material complicated. Let's try to make a material which basically goes straight forward. You just grind it, you place it on a platinum pin, you put it in the furnace, you start your program, you don't need anything special, and you go to this crystallization process. And the crystallization process, it's about an 8 minutes hold. I think about the whole rise, I think it's about around 12 minutes, so it's about a 20 minutes process. We don't have to do this. On the blue blocks, you have to put like a paste into them or something like that to crystallize that. We don't need that with Suprinity. Like I said, we just put it on the platinum pins. This is all time-consuming, like you see here on the blue blocks. Okay, we don't want to do this because if the material has been designed right from the manufacturing point, then you don't need all these steps. We don't get any distortion. What we don't want to do is put ceramic pins in here, because during the heating process, the ceramic here will expand, the pin will maybe slip in, and then your crown could crack. That's why we want platinum pins. So once your Suprinity has been milled, like you see here, you can cut it back if you want. I would recommend to cut it back before and not afterwards. But let's say you forgot to cut it back in the first stage, you can cut it back afterwards, like you see here, and then you can add porcelain. Usually only do that if you have very tricky anterior restorations where you want to have enamel or stuff like that on it. But if you're doing 4 anteriors, you don't have to cut it back at all. Nowadays, patients even complain when you put enamel on it because they say it looks too gray. They want it just one tooth colored. The ceramic which goes on it is called VM11. It's a new porcelain which had to be matched the coefficient expansion, and this VM11 really goes on very easy, very straightforward. Again, it's a no-brainer. Then on the staining side, we use the new accent stains from VITA and the glaze LT. This glaze LT is a low-temperature glaze, so we can fire it at the lower temperatures. You put those glaze on, you put the stains on, and you basically glaze it. If you want, you can actually also use the glaze sprays like you see here, and you can spray these glaze on. Just a little bit caution that you don't get glaze into the crowns. On a single crown, you just have to hold the glaze from top and spray down. It works. Or basically use the brush with the liquid. So VITA thought about everything that they try to make. If somebody wants to spray it, they can spray it. If somebody wants to glaze it with the paste, they can glaze it with the paste. And then you can polish these things very easily in the patient's mouth. And like I said, the polishing process is very, very easy. It polishes very, very nice because the structure of this material is very fine. You saw one of the first pictures what a fine grain material this was. Okay, and the product is put in the mouth and finished. So you see they look okay, they look nice. And again, not much effort has been taken to make these two veneers. And that's what we're looking for, this type of material. Most of the blocks which I use is the HT, the high translucent blocks, because they have a better chameleon effect. You can actually do veneers, you can do crowns, you can do whatever you want with this type of material. Strength-wise, basically, people recommend to adhesively bond it. So they say, what shall we use? I would basically say do whatever you're doing with Emacs, because they are very similar materials, and so whatever success rate you had with Emacs, do the same thing with Suprinity. You see very nicely on this picture also that these four, how they were clear, how you can see through them here. Then went through the crystallization process. You see it comes out shiny like this, and then just stained it here, and the crowns are finished. And you can see how thin they are here, extremely thin, these crowns. Now, The next two crowns are abutment crowns. And when you look at these abutment crowns, you will see something very interesting. You see that this one looks gray and this one doesn't look gray. And I want to show you in the next few slides what I do to stop my abutments becoming gray. Because this is still a problem which is still around, that very often your abutments have a tendency of picking up the color from the titanium base underneath, or if you have a titanium base in the patient's mouth and you're just putting a thin crown on it, basically it tends to look a bit gray from underneath. You know, people say, I just use an opaque bonding material, but you forget that your gap is maybe only 50 microns, you know, sometimes 40 microns, you know, thickness of a hair. And if you take the thickness of a hair and you try to mask it with the standard, let's say, multi-link opaque, they're not opaque enough, and then it still shines through gray. So we have to do something else. But before that, I would like to mention something here. You know, for me, and you know, many people will be kind of upset with me, is makes no sense to have blocks with holes. I just don't understand why we are having blocks with holes. I just don't understand that. You know, if you use other systems, for example, 3Shape, or if you use Exocad or Dental Wings, all these systems have in their software basically the whole design. The design of the whole is done industrial CAD/CAM, okay? So all the measurements are in the software, and these measurements are put into your design. So basically this design here is then plugged into your abutment crown which you've designed, and the computer knows how to mill it. Now, this could be done very easy also with Zirconia. CEREC could do that very, very easy, but it seems that nobody wants to do it, and I don't understand why. Because for me, having a block with hole is too expensive. You pay so much money for somebody drilling that hole for you. If you can have the hole put in with CAD/CAM, the right design, your machine can mill it. Now, if you say, no, my machine doesn't mill accurate, that means you're using the wrong machine. Because if you're using an MCXL, you can also mill a lower anterior crown. A lower anterior crown has also got a very small hole, and you can mill it. So for me, CEREC mills very accurate, and CEREC, I could mill something like this if the design has been calculated, put into the crown, into the abutment like you see here, and then my machine can very nicely mill it. That's why I think we just have to put pressure onto Zirconia, all of us, and say, hey, look, we don't want to spend extra money for buying blocks with holes. We want to use blocks which we want. So put this into the software, and then we can grind it. Because I think there's no future buying these too expensive blocks. You know, I'm sure VITA will do that with the Suprinity too. I'm sure they're going to make blocks with holes. But like I said, I don't want to do that. I want to mill them. So let's go back again to how we mask out our abutments. So when we look at our abutments, the first thing is I take the, let me just see here where my thing is here. I take the implant model analog, I put it in putty material like you see here, so only the abutment is sticking out. Then I put a little piece of foam into here, and now I can sandblast this whole thing. So now I have to sandblast it with 250 microns, and by putting in this putty material, I don't hurt the underneath side of these, or the connecting side of this abutment. So it's been sandblasted. After sandblasting, I clean out this, I take out this foam piece, and then I use a product called HLC Bond. And this is a fantastic product. I think VITA is going to discontinue it. So we have purchased a lot of these bottles and this paste. You paint this on, like you see here, and you take a paint stripper, and you heat this up, and it starts steaming, and it bonds it, and it fuses it to your metal frame. And now basically we have masked out completely our titanium abutment. And you can do that in a dental office. And you can do this in any abutment which you have. So if you have an abutment which is going to be cemented in the mouth, and you have a very thin crown, this is the only way you can mask it out. It's a fantastic product, was never made for implants. This product was basically made for veneering metals with composite. And I've been using it for this, and I hope VITA is going to maybe not discontinue it. So by putting this on here, you can see this crown looks much lighter. If I don't put it on, you see the crown or the abutment looks grayer. By the way, what I recommend when you use abutment, use the Suprinity T blocks. The T blocks are the blocks which have less translucency. So they are better for doing abutments. The HD blocks are the high translucent. They're better for doing crowns on them. The whole processing is done with the MCXL. And just the last few points, which I think, like I said, Emax is the product which we have all been using. But 5 improvements which can be done to that material and make a new material better is, first of all, we have the better fit because of the edge stability. We have less chipping. It's very easy to polish, so it's much faster to finish the crowns. You get more strength, about 100 megapascal more compared to lithium disilicate. You don't need any firing support, like any paste or anything like that. And you don't need any special furnace, okay? You can use any conventional furnace. So these are a few of the points. The aesthetic point is naturally also an issue and all that, which makes Suprinity nicer, but that's a very subjective point. I find it nice, somebody else will maybe not find it good, but these 5 points are really showing up, and people have been saying because of these 5 points they have been liking to use it. And this is the last picture. In German we say Blau ist die Hoffnung, blue is hope. So I think Suprinity, you will see in the future, will take a marketplace if they allow it to be sold in the U.S. because there are some issues still happening. In other countries, I've done a few courses now in Hong Kong and in Taiwan, and the dentists there, they really they love it, and they say the aesthetics of it, especially as a chairside product, is fantastic. So thank you, and I hope you enjoyed this kind of informal presentation.
Thanks, Vanik. Really appreciate your expertise in this area. We have a little time for if anyone has any questions out there for Vanik. Just type them into the computer. While we're waiting, like I said before, Vanik will be at the Scientific Symposium in October in Las Vegas, along with other great speakers. A question, Vanik. One of the questions is, can this be used for a bridge?
Yeah, good question. Okay. Yes and no. First of all, no, because they don't have the large blocks as yet. Okay. So that says one thing, no. The thing is, from the strength numbers which you have been seeing, the AG Ceramic in Germany it's like a group recommend anything over a certain megapascal would allow to make bridges. So basically, anterior bridges could be made out of this material, but VITA will not recommend it until there is enough field testing happened. What we have been seeing is if we design it on some of the softwares which are on the market and try to make bridges, it gives us connectors which are huge, huge connectors, because the software says, okay, this material has got so many megapascal, and the size of the bridge means diameter of the connector has to be so much. So usually what you would go, and you would anyhow thin it down, which would maybe make it weaker. So, I think we will see bridges made out of it, because people are now starting to do bridges out of Emax. So if you do bridges out of Emax, which is a weaker material, then why wouldn't we be able to do bridges out of this material?
Okay, Vanik, how long is the firing to go from clear to color?
It's around I think it's a 20-minute cycle. I think it's about 22 to 24 minutes. It's about a 20-minute cycle. 8 and Yeah, about 20 minutes, yeah.
Okay. Does that HLC bond prevent complete seating of the hybrid abutments on tie bases?
What I did not what you meant.
Well, you know, you put that material on and you fired it to mask out, and let's say you're just you're doing almost like a screw retained crown on top of that. Would that prevent the seating of that?
No, because what happens is we use that HLC bond for most of the crowns are screw retained, which we do, and so when you paint that HLC bond on, you don't paint it from underneath. It's only on the tie base. So you bond your crown to it before.
Okay, when you're staining and glazing, are you doing it, and firing the material? Are you doing that all in one step? How long does that take?
Okay. Okay. Let me just get to this point. Now there are two things we can do. This has nothing to do now with tie base. Okay, the titanium base. When we put the opaque on, that means it's the finished crown. It's already glazed. Everything is finished. Only then we put that opaque on. Okay.
Okay.
So we don't fire it on that. We don't fire it on the titanium base.
Okay.
Okay. So that's one side of it. But the other thing, which the question also goes is, can we basically do the whole staining with the crystallization process?
Yes.
Like that means I polish it, I add stains to it, and you can do actually the whole thing in one shot. So you basically, I would then polish it, and then I would put the stains to it, and then finish it. Sure, I'm the only one who's polishing it, but 90% are not polishing it. So they basically just put the glaze on and the stains, and they do everything with the crystallization process. There's no problem there.
Okay. And I think this was on one of the slides, but we just want to be sure. What was the approximate milling time compared to Emax?
It's not really significantly. I would say it's about a minute and a half, like that. Less, about between 1 and 2 minutes. It's not really a big issue.
And the firing time's around 20 minutes, correct?
Yeah.
Okay.
So it's everywhere a little bit faster, and that's why when I was showing the processing, I put it in front of the Emax. It's a little bit faster, but it's not really dramatically faster.
All righty. I'm going to try to decipher this. What tie base were you using there, and where do you order it, or is it even available here in the States?
I'm sure it's available here in the States. There are two companies which are selling tie base back in Europe, which are like known companies, and the one is called Medentika. And Medentika, you can look on, you can Google Medentika, and you'll see all the tie bases. And I'm sure they sell it in the U.S. And the other company is called NT Trading. It's also a German company. I'm sure they sell it. Now, Medentika has just been purchased by Straumann. It's now a Straumann-owned company.
Oh.
Okay? And they make tie bases for all systems, from Astra to basically for everybody. They make tie bases. And what they have done is all the tie base information, basically the way the hole has to be in the software, they've got it for most of the CAD/CAM systems. So most of the systems, and free, most of the CAD/CAM systems use basically the drawings from Medentika in their software for the whole. And that's what I would love Sirona to do, is basically, integrate it into the software would be easy. And then we would not have to have blocks with holes.
Okay, Vanik, what is preferred polishing method before firing? That greenstone and the gray wheel, is that correct?
The greenstone is just to remove, any, anything which, like the sprue and those kind of things, because you should not do too much grinding, because otherwise all your benefits which you had when you were designing are gone.
Okay.
You try to design it pretty good, so you only need a little bit grinding, maybe the length, maybe the contact a little bit, and then I use that gray wheel which you saw there. That it's a pre-polishing wheel, and then either the diamond paste, or what really works very good is the gray. It's a gray colored polishing wheel for enamic.
Okay.
I'm sure for the high shine. If you use
Right.
that gray polishing wheel, it just comes out like perfectly. I mean, it's perfect.
Are the firing protocols available for, somewhere for to program into other ovens?
Yes, I think on I mean the firing temperatures are you can download them or they're in the instruction manual for Suprinity.
Okay.
But what's happening is some of the other companies who are selling furnaces, some of the reps will not program it in, or they don't want to do it. So it just it depends how much pressure you put on them.
Well,
The numbers are there.
Yeah.
Yeah.
CEREC doctor mentors are pretty resourceful, so if they have the firing temperatures, I'm sure they can get them in.
Exactly.
What's the minimum clearance for the prep for Suprinity?
You mean the minimum reduction?
Yes.
I didn't put that slide on. Usually, what we have is about 1.2. In that region, 1.2, 1.3. That's about what we are.
What you're doing. So
what
jokingly, if that's what you're doing, then most dentists listening in this will try 1.0.
Yes, exactly. I mean, what happens is at the end of the day, the margin anyhow becomes thinner.
Gotcha.
My biggest concern with all these, I'm never worried on these preps on the anterior and on the marginal side. Just on the back side, that's where I'm worried. On the lingual or the palatal side. Those are areas which are uncontrollable, because then you bond it, the patient makes the protrusion movement and all that, and then you start grinding there, and then it becomes paper thin.
Gotcha.
That's where I'm more concerned.
Well, listen, Vanik, we appreciate your time here tonight and your expertise. We're all looking forward to seeing you in Vegas in October, and thanks to everyone for listening tonight. And we will bid you now a fond adieu. Thanks very much.
Thank you very much, Mark. Thank you. And see you in Las Vegas. Looking forward.
Looking forward to it. Bye-bye.
Thank you. Bye-bye.